It's Mr. Brew from Infinity the Math Institute. Sorry I'm running 2 minutes late. I had to go back in the makeup room and fix my hair. I'm just going to wait a couple of minutes until you guys gather around. I've got a really exciting lesson set up for today. We're going to be talking a lot about the equation of a line because it's something that you learn in middle school and it's something you need to have mastered throughout high school. You'll never survive geometry, algebra 2, or pre-calculus and graphing polynomials and sinusoidal graphs if you can't graph a line. And a line is a great little lesson for you to start seeing the connection between the algebraic and the geometric world. The one thing you need to know is that there isn't such a thing as math people and non-math people. What you actually have is you have algebra people and geometry people. Algebra people are known as the math people, are the ones who love computations. You love all the properties of equations and adding and subtracting and multiplying and doing long problems with lots of numbers and letters. And those are the algebra people known as the math people. The people usually known as non-math people are actually just geometric people. People who like to see things, like to visualize. They like charts and graphs, and they like to draw the line as opposed to figure out the line with the numbers and the computations. And that's the only difference. That is true. But everybody's a math person. Math is just common sense and logic. Math is just 1 plus 1 is 2. Math is just, how fast are you going? 30 miles an hour. It's just quantifying or putting a number or a value to something. That's all math is. All we're doing is counting or quantifying something. Easy enough? All right. So, like I said, today we're going to be talking about the equation of a line. And what I want to do is because I've been getting a lot of questions about lines, systems of equations, inequalities, and all of these subjects all revolve around one premise, the equation of a line. So in order to answer like 3 or 4 of the questions I've received this week, I'm just going to teach you guys everything there is to know about a line. And I don't care if you're in 11th grade and you're in pre-calculus, or if you're in 5th grade and you're about to join middle school. This is something that if you have it mastered, it's going to make your life a lot easier. So, please take notes with me if you would. Equation of a line. First things first, you have to understand that you have the equation of a line when you have a constant rate of change. Constant rate of change. Rate of change is something you're going to hear a lot from now on. If you're a high schooler, then you know that everything's going to be about the rate of change. If you're a middle schooler, trust me, or ask the high schoolers. All right? The rate of change is actually called the slope. That is the single most important definition of all of middle school, and you need to just truly understand. Slope is the rate of change. That's all it is. The two go hand in hand. If somebody says slope, just understand they're talking about the rate of change. If somebody says rate of change, just understand they're talking about the slope. Slope is represented by the letter M. Everybody. That's always the first question. The kids who sit in the back of the classroom and they don't say a word for 4 months. They do absolutely no work. And then I get to this part of the lesson, 4 months into our relationship. I still haven't even heard the kid's voice yet. And I'm like, we say slope is represented by the letter M. Why M? Why isn't it S? Everybody wants to know why slope is represented by the letter M. Even the kids who have no interest in math or school at all of a sudden everybody wants to know why M. I'll tell you why. M was given its designation by a French mathematician, and in French, the word slope is something like monte or something like that, M-O-N-T-E or something like that. So the reason slope is represented with the letter M is because it's actually representing the word monte or whatever the French word for slope is. You only get that kind of golden nugget information at Infinity the Math Institute. So, M is, what is slope? It's the rate of change, or it's the rise over run. Rise over run. You guys all understand that? When we're talking about rise, we're talking about the change in y, or delta y, over the change in x, or delta x. That triangle, remember, you're going to see it a lot. It means change in. And anytime we have delta y, or change in y, it will be the second y coordinate minus the first y coordinate. Anytime, and you will see it, delta x every time is going to be x2 minus x1. So slope is the rate of change, represented by the letter m, which is rise over run, delta y over delta x, or the actual formula, textbook formula, is y2 minus y1 over x2 minus x1. All right. Now that you understand slope, well, let's just make sure you understand slope. Let me give you the 4 examples of slope, just to make sure you understand. All right, we have 4 different types. One is going up. That's going to be a positive slope. One is going down. That's going to be a negative slope. As the input increases, the output increases. On the second one, as the input increases, the output decreases. Very simple. The ones that everybody has a lot of trouble with are the horizontal and vertical lines. All right? You got to understand, as the input changes on the third one, the output does not change. What is the rate of change? It's 0. On the fourth one, as the input increases, the x value never increases. It's a vertical line. So that is undefined. It just doesn't make sense. Delta x is the denominator, and there is no change of x. And if you have a 0 in the denominator, it's undefined. We all know that, right? Let me teach you a little trick. Even though you should understand the concept now, even the best mathematicians get some things confused sometimes. What you want to remember is that horizontal line in the third graph, you can make that into a z for 0 slope. That vertical line in the fourth graph, you can make that a u for undefined. And you can't do that the other way around. So now you have no excuse. 0 slope, undefined slope. Now, we totally understand slope, right? That's the most important thing. We'll get into equations of lines. Hey, everybody. All right, so our first equation of a line is called slope-intercept. I don't like that color. Slope-intercept. Now, what do you think you're going to be given when you're working with slope-intercept? Right, the slope and the intercept. It's really that simple. And most of you should recall, right? Y equals mx plus b. Now, anytime you have a linear equation, you're going to have an x variable and a y variable, right? So, x and y will always be variables. So let me label that for you. Variables. All right, m, guess what m is? We only talked about it for the last 10 minutes, right? M is the slope. And then I'll give you one guess what b is. Yes, it's the intercept. Which one? The y-intercept. So the slope-intercept equation of a line is y equals mx plus b. The next one, which is very useful, is called point slope. You'll never guess what you're given with point slope equation. Yes, the point and the slope. Holy cow. Unbelievable, right? Y minus y1 equals mx minus x1. Where, what are x and y? They're still the variables, right? X and y are variables. What are x1 and y1? That's going to be your given point. And m, Monte slope. It's as easy as that, guys. And just understand that these two equations are the same. They're just a different way of representing the information. But they're going to represent the same line. They're the same equation. We're just doing one side. I'm doing the same thing to the other side. Just my basic principles of algebra will lead me to the fact that these are the same equation, just represented in a different way. And this last line is also the same line, but it's not very functional. We have it for aesthetic purposes only. It really just looks nice. We call it standard form. Hold on, let me get back to my green. And the standard form equation of a line is the prettiest one. It's ax plus by equals c. And you can see that looks really pretty. And what's even more important, well, not even more important, but what's important and keeps it so pretty is that we have to make sure that a, b, and c, these coefficients and constants, are elements of the integers. Z with a double stem is the abbreviation for integers. You might have remembered that from one of the previous lessons. So those coefficients A, B, and C have to be whole numbers or their opposites, an integer. They cannot be fractions. They cannot be decimals. And that's as simple as that. Those are your three different equations of a line and what each thing stands for. I mean, I'm telling you right now, if you would, take a picture with your cell phone, pause the video, write this down. These are your three equations of a line. And we're going to go through an example and be able to represent all three of these equations. But, of course, there's a couple of special cases. And sometimes when you're taking a test, they'll tell you which form they want you to answer the question in, and you'll be able to do it. But with these special exceptions, it doesn't even matter what way they want you to answer the question. There's only one way to answer it. And again, that's with our horizontal and vertical lines. You remember this horizontal line has a zero slope, right? We could make a Z and we know it's a zero slope. No problem. What you need to know is the equation. Pretend this crosses the y-axis at c, or 2, or 3, or whatever number that is. The equation is y equals c. That's the equation of that horizontal line. All right? X changes. It goes back and forth. But the height, the y, is always staying the same. So y equals whatever that number is. I have it as c. It could be 5. It could be pi. Whatever. Y equals whatever that number is. And as you may have guessed, the vertical line, the y, the height, changes. But the x does not. The x remains constant. So we'll call this c. And the equation of this line is x equals c. And let me repeat what I just said. It doesn't matter what form they're looking for the answer in. If you're taking the SAT and they say, please answer in standard form, or you're taking a test in your Algebra 1 class and they say answer in point slope form, no matter what form they're looking for, if it's a horizontal or vertical line, there's no other way to express it than those two equations, all right? Very good. And that's about it. One little thing for you guys, especially in geometry and algebra 2, regarding the slope that you might want to remember. Parallel lines have the same slope, which you could tell by looking at it, right? They both go up and over the same amount. That's how they remain parallel. So parallel lines have the same slope. If the slope of one of the lines is 2, the slope of the parallel line is 2. And then we have perpendicular lines. These perpendicular lines have a very specific slope too. I could get into the proof with you, but for right now, I just want you to take the notes. It's the negative reciprocal. I can't say negative reciprocal and write perpendicular at the same time. I'm so sorry. Perpendicular have negative reciprocal slopes. Remember, negative or opposite and reciprocal, two numbers whose product is 1, you could think flip. The negative reciprocal of A over B is negative B over A. If the lines are perpendicular and the slope is equal to 2, the negative reciprocal slope is going to be negative 1 over 2. If the slope of one line is negative 2/3, the slope of a perpendicular line would be equal to positive 3 over 2. Negative reciprocal. And guys, I mean, if I'm going to tell you about all that, that's basically everything there is to know. All right, before we get into a problem, let's review. The equation of a line means a constant rate of change. Rate of change is slope. It's represented by the letter m, which is rise over run. Could be represented by the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Those would be your given points. If the graph is going up, it's a positive slope. If the graph is going down from left to right, it's a negative slope. A horizontal line is a 0 slope, and a vertical line is an undefined slope. Your three equations of a line are standard form, ax plus by equals c. Your slope-intercept equation gives you a slope and an intercept. Y equals mx plus b, where m is the slope, b is the y-intercept. And then the point slope is y minus y1 equals m x minus x1. I'm sorry. So I was talking about the y-intercept, all right? Just in case you're not sure what that is, let me be clear. The y-intercept, geometrically, visually, is where it crosses the y-axis. Algebraically, the y-intercept is the value of y when x equals 0. And guess what the x-intercept is? Yep. The x-intercept is the value of x when y equals 0. And for my geometry people, what does it mean geometrically? It's the value of x when y equals 0 algebraically. Geometrically, it's where it crosses the x-axis. So, let's take a look at a line. All right. Now, all you algebra people probably love the first half of the lesson. You geometry people are going to love it now. All you got to do is look at the line. Right here, geometrically, you could see that the y-intercept is equal to -3. It crosses the y-axis at -3. And we know that that's represented by the letter b. So b is -3. Then if we want to talk about the slope a little bit, all you got to do is find another point. The closest point makes it the easiest. And the rise over run, which is the slope, is equal to, what's the rise? It goes up 2. So the rise is +2. And the run is right 1, which is +1. And 2 over 1 is the slope. Slope is m, is equal to 2. And then, to put it into slope-intercept form, y equals mx plus b. Well, x and y are the variables. We said that earlier. So y equals m is 2. So it's 2x. And b is -3. So plus -3 or -3. That is the equation of that line. Y equals 2x minus 3. Y equals mx plus b. What if we wanted to put it in standard form? Well, then we take y equals 2x minus 3, and we want it to be ax plus by equals c. So what's the problem? Well, from where I can see, the x is on the wrong side of the equal sign. So let's subtract 2x from both sides, and you get y minus 2x, right? But notice what standard form is. We want our x's first. So even though it would look prettier to write y minus 2x, we're actually going to write -2x plus y. And what's left on the other side, -3 is still there. And there you go. You got it in standard form. It was that easy. Remember, there can be no fractions at decimals, but in this instance, there are no fractions at decimals, so there's nothing to worry about. If you're a real freak like me, you want your standard form to be even a little bit neater. And to do that, you can multiply both sides, or divide both sides, by -1. All that actually does is change the polarity of everything, giving you 2x minus y equals 3, which I think is just a little bit neater. So the -2x plus y equals -3 is an acceptable true form of standard form, but the real nerds like that leading coefficient, the coefficient in front of the x, to be positive. And all you got to do is multiply it by -1. Anything you do to one side, you got to do to the other. The last one, we have point slope. You see this point right here? That point right there is at 1, right 1, down 1, right? 1, -1 is this point. All right? And I'm going to do a point slope equation. I could have used the intercept, but that includes a 0. When I do point slope, I don't like any zeros, and you should be able to see why. So I got the point 1, -1, and I know that the slope is equal to 2. And I know my point slope form is y minus y1 equals mx minus x1. So my given point is giving me my x1 and my y1. That's where I get the x1 and y1 from, the given point. The slope, self-explanatory, I already know it's 2. So y minus y1, so y minus -1, or y plus 1, is equal to m, which is 2. X is a variable, minus x1, minus 1. And that's it. That's the point slope form of that line. And again, I told you, All three of these are the same thing. All three of those equations represent the same line. I'll prove it real quick if you'd like. I got to distribute the 2. So y plus 1 equals 2x minus 2. I got to subtract 1 from both sides. So y equals 2x minus 3, which I already know is the same as that standard form and the same as that slope-intercept. So that just shows you all three of these lines are the same exact thing. Beautiful. And that's it. I mean, we do have the x and y intercepts. That's a good little way to finish off. You could see at that red dot right in the middle of the screen, that's the y-intercept, right? We already said the y-intercept is -3, right? Y-intercept is equal to -3. Sometimes they'll ask for an ordered pair. It would be 0, -3. Now the x-intercept, it doesn't cross at an exact perfect intersection. So that's when you're going to have to pull out some algebra. Now those of you with a little bit of common sense can see that it's 1.5 or 3/2. But anytime it's not exactly perfectly obvious, you got to do it algebraically. What is the x-intercept? The x-intercept is the value of x when y equals 0. So I'm going to take this equation right here. It's the value of x, so 2x minus when y equals 0. So instead of y, I'm just going to write 0 equals 3. So 2x equals 3, and I divide both sides by 2, and x equals 3/2. So we were right. It is 1.5. But like I said, unless it's really crossing that intersection, do it algebraically just to be sure. It's really easy. Just set the y value equal to 0 to get the x-intercept. To get the y-intercept, just set the x value equal to 0. And that's really it, guys. The x-intercept is sometimes known as the root. And that will be very important in Algebra 2 pre-calc and calculus. So just remember, the x-intercept is a synonym for the root or the 0 of the equation. And that is everything equation of a line. I didn't do any parallel perpendicular problems, but other than that, I mean, that is literally 2 months worth of middle school equation of a line. Sometimes even 3 or 4 months, because it's that important and kids have that much trouble with it. But you shouldn't, especially if you just took really good notes at the beginning. All right? Everything you need is right here. The equation of a line's definition. You got to understand slope. You got to know the 3 equations of a line. And that's it. The special cases, horizontal line is a slope of 0 and the equation is y equals c. A vertical line, the slope is undefined and the equation is x equals c. X-intercept, y-intercept. That's it, guys. That's everything equation of a line. Super slow and meticulous, but that's it. So, if you have any questions about this particular lesson or how it applies to your lesson, just send us your questions. We're going to be here every Wednesday night at 7 o'clock, and the more questions, the better. I hope that helped all of you that were working on equation of a line, and we'll be able to apply that very easily to inequalities in systems. So, again, we're live, YouTube and Facebook Live. You could always visit our website, themathinstitute.com. Give us a call, 702-768-1777. Our favorite thing, especially as things begin to open up and the sun is coming out, spring is coming, and we're looking forward to seeing everybody in person, and we're right on Flamingo Road about 3 miles west of the Strip. If you know where the Palms is, 2 miles west of the Palms. The Gold Coast, great employment center over the Gold Coast. Everybody loves the Gold Coast. But the number one destination for Las Vegas is Infinity the Math Institute, because we don't give you more math problems. We give you solutions.